Rare earth elements. What are they and why are they important? Well, there are 17 elements that are classified as rare earths. That includes the 15 lanthanides, and that starts with the element lanthanum on the periodic table, but also includes 14 others that are along a row, one of the two rows at the bottom of the periodic table. As well, it includes the elements scandium and yttrium that are located just above lanthanum on the periodic table. Those are included because they occur in the same mineral deposits as the lanthanides. As well, they have some similar chemical characteristics as the lanthanides, although they do have some different magnetic and electrical characteristics. Rare earth elements are classified as light rare earth elements and heavy rare earth elements, or you may even see intermediate rare earth elements in some classifications. This is broadly based on their atomic number or atomic mass. Generally, those with atomic mass up to about 61 or 62 are classified as light rare earths, whereas those above that are classified as heavy. But again, this depends on the particular source and their classification. Now, in spite of the name, the rare earth elements are not necessarily particularly rare. However, it took time historically to isolate and identify them, and they are spread thinly as trace impurities in most regions on the Earth, except rare deposits. Cerium, the most abundant rare earth element, is overall the 25th most common element in the Earth's crust. That makes it more common than copper, for example. Overall, the rare earth elements are more abundant than precious metals, particularly gold and the platinum group metals. However, they are more rare than most other industrial or base metals. Now, what are rare earth elements used for? The top use is for permanent magnets. And there are two main types of rare earth element-based permanent magnets. First, neodymium magnets, which contain neodymium, obviously, as well as iron and boron. And these are the strongest known permanent magnets at room temperature. As well, the second leading type are samarium cobalt magnets. These offer better performance at high temperatures. Now, these powerful rare earth element magnets are used in a variety of applications, particularly high performance applications in electronics, defense, and energy. One example is that they're included in smartphones. They're used both for vibration motors, that includes a small neodymium magnet that, if you have your phone on vibrate mode, it'll provide the vibration. As well, these magnets are used for magnetic accessories, such as car mounts and cases that may have a magnetic element to them. Rare earth elements are also used in a variety of other applications, particularly catalysts, polishes, various alloys and metallurgy, as well as batteries, and some specialty glasses. And there are some important defense applications as well. And the US government has classified the little-known element of dysprosium as one key rare earth element of strategic interest. Now, the use of rare earth elements is growing and is expected to continue to grow, perhaps at an accelerated pace. A study at Belgian Research University, KU Leuven, predicts that 7 to 26 times more rare earth elements will be needed by Europe alone to meet its 2050 climate targets. As well, perhaps a bit more conservative, the International Energy Agency predicts that demand in 2040 could be 3 to 7 times higher than it is today. Unsurprisingly, as a result, rare earth elements are classified as critical by the US, European Union, and the United Kingdom. So, why have rare earth elements been in the news in recent months and years? Well, it's primarily geopolitics and the location of production and processing of the rare earth elements. Particularly, China now dominates production. According to rareearths.com, in 2024, China accounted for 69% of global production. Historically, the US had been the dominant producer, particularly through the Mountain Pass mine in California. But starting in the 1990s, China really ramped up production and overtook the lead role in production. The Mountain Pass mine was actually shut down for a while because of the glut of supply out of China, although it has since been brought back into production. China has very rich deposits of rare earth elements that include both the light rare elements and the heavy rare earth elements. These largely are in Inner Mongolia, although there are some deposits in the south of the country as well. Now, there have been efforts in recent years and over the past decade to look at alternatives to China and bring production online elsewhere. And there have been mines brought on and some production out of Australia, obviously the Mountain Pass mine out of the US. There is some production out of Myanmar, and a lot of that goes to China. As well, there's some growing production out of Thailand. But there are efforts in North America to look at increased production here, both within the United States and Canada. There are several deposits known in Canada that are being advanced, and even one project in Greenland that is fairly rich in rare earth elements, and people are eyeing for development. If you found this video useful, informative, and interesting, please like and subscribe. And please look at our other videos as well. We'll continue to produce videos on metals, mining, and investing in the metals and mining space.